But this is the part we're going to deal with first because we need to figure out how much time we're dealing with here. And to figure out how high it goes, the actual height, we're going to need to calculate that. Well, how do we do that? Well, so what's going on here is that this is going to go up and then come back down. Okay, so we're looking at this point right here. Now, because the beginning and ending point are, shall we say, symmetrical to each other, this is going to divide it exactly in half. I'm going to call that t sub 1/2. That's the half time for the object to be in the air, the cannonball. And we know that it's going to be the same. Well, so as this goes up, and we're trying to find the height, which is the distance of that, we need the time. Why? Because we're given the initial velocity of 175. This is the initial velocity going up. So we're going to use VIT plus 1/2 AT squared. Where A is G, VI then is 175. But we need T to find D or H, or however you want to look at it. Well, this is one of those scenarios we're going to have to use another formula to get that piece of information, but that is basically going to come from the definition of acceleration. And acceleration is defined as VF minus VI over T. And in this case, acceleration is G. Okay? So, we want to rewrite this so that G is by itself. So we're going to flip-flop the G and the T, and this is going to be T equals VF minus VI over G. Well, is it really G though in this case? Well, we know that the cannonball is going up. Is that going to accelerate as it goes up? No, it's not. It's going to decelerate. So technically, this is negative G. This would be negative G here. Okay? Since it's going to be negative 9.80 meters per second squared of acceleration, or positive 9.80 meters per second squared in deceleration, but in relation to what's happening with our velocities here, it has to be negative in order to make this equation work. So the final velocity as it reaches to this point right here is going to be 0. So we'll just drop that out of there. And when we drop that out of there, look what we got. A negative divided by negative, which means it's going to be all positives. So the time is going to be the initial velocity, which we established for the vertical part, like I said, is 175 meters per second, divided by G, which is, now we're using the positive G, not the negative G, 9.80 meters per second squared. Okay? Now I just divide those two out, or I cheat a little bit and look at my script and see what I got. What do I got? What have I got here? I got a T of 17.9 seconds. But that's not really T as much as it is like this T right here. So I'm going to put T sub 1/2 is 17.9 seconds. Now, how high up did it go? So let's not do the horizontal to get all the vertical stuff completed here, shall we? Well, the formula for that, find this height right here that we're trying to get out of this. Well, look, we got D equals VIT, plus 1/2 GT squared. So we're going to use that formula right there. So you got 175 times the time, 17.9 seconds, plus, I'll put this down here, 0.5 times, now again, this is actually negative G because it's going out. Negative 9.80 meters per second squared times 17.9 seconds quantity squared. So there is our formula for our height. And our height then, again, cheating time, yay, yes. Cheating time tells us it's going to reach a height of 1,570 meters. That's 1.5 kilometers, which is really high. It might even hit a low-flying plane if we're not careful. So we better make sure that the FAA knows we're shooting off cannons here, not going to be smacking any low-flying planes like maybe crop dusting or something, although people are probably done crop dusting at this point of the season. Now we can do the horizontal velocity to find the distance, horizontal distance. And the formula we're going to use for that, because again, that is a non-accelerating portion of the motion. But in order to do that, we need the total time, t tot, is going to be half time, 17.9 seconds, times 2, so that's going to be 35.8 seconds. So we're going to use that for our horizontal aspect. So the height is going to equal to VI, which we said is 175 meters per second, times the time, which we said is 35.8 seconds, plus 1/2 times, now again, you're going up, so it's no longer accelerating, it's decelerating, so that becomes a negative 9.80 meters per second squared, times 35.8 seconds quantity squared. A lot of people forget that too. You gotta be careful of that. Otherwise, you run the danger of getting 0. Well, no, not 0, actually a much higher the number than you should. And regardless, whatever you did, it's not right. But if you check it out, oh my goodness, I used the wrong formula for that. Yikes, we're not accelerating, moron. But let's pretend like I didn't do that. Actually, I'll cut it out. So now, we're going to get rid of that. So we're going to pick it up from where we did the 35.8. And now, since it's non-accelerating, d equals vt, that's our height. D equals the horizontal velocity, which is 303 meters per second, times 35.8 seconds. And the answer for that will be 10,800 meters. So it's going to go about just short of 11 kilometers, which is in the neighborhood of 7 miles. Go war weapons.